So our goal in section 8.2 is to perform something called synthetic division. And synthetic division is just a clever way to divide a polynomial by a binomial. Now, I've shown you three different equivalent expressions here. I think this is problem number 22. But right now, I just want you to get comfortable with the idea that there's lots of different ways that you can write essentially the same problem. So you can just write it as a quotient, you can write it as the division of these two polynomials, or you could have something set up to do kind of long division. And it's really long division that inspires synthetic division. Long division really lives up to its name. Let's take a look at it using the example in the section. So here's an example of long division. Oops. This is page A2. So it kind of really lives up to its name. You're dividing this polynomial or this binomial into this polynomial, and it's just a lot of work. You have to figure out, well, what do I multiply this by to get this, and multiply that by the whole binomial, and then what you don't really see here is you're subtracting here, change the signs, and add. This is a good 10-point problem when you take my Math 1100 class. It's not a slouch of a problem at all. But when you start looking at this repeatedly and carefully, what you can do is start removing all the x's and just kind of keeping track of these things by their places. And then start looking at the coefficients that are left and realizing that we can kind of take a little bit of a shortcut here. So let's keep an eye on this answer right here. 4x squared plus 3x minus 5. The way synthetic division is going to work is that we're going to take and put just a number out in front and then work with all the coefficients. So we start slimming down this process. And just work with all the coefficients. So let's see, there's the number 2. And let's see, I think I might want to better, no. Let's come over here. This is kind of more refined. So I take that number minus 2. I've got it out in front. And, oh, I'm sorry. Thank you. So that number minus 2 comes out in front. Here's a... Dang, sorry, it's twice in a row. Thank you. You know what? Let's do this. There we go. So take that number 2, negative 2, put it out in front. These are all the coefficients of our polynomial, and these are the coefficients of our answer. The only thing that we have to understand is what this is. And that 10 was actually the remainder for our division. So somehow or another we've slimmed down this process tremendously so that we have just this little bit of work to do. That's a nice savings in work compared to what we started out with. So let me explain how this all works, what you're doing when you're doing a synthetic division problem. And let's see, we'll do that with, in particular with problem number 20 to kind of get started with. So kind of a friendly start to these problems. Now there's a couple ways I think that we can do problem number 20. Let me zoom out a little bit. There we go. First let me write it down. Problem 20. What's that? Yeah, it's in the back of the book. Is x squared plus 13x plus 42 divided by x plus 6. So we'll start by writing ourselves this little sign here. It looks kind of like a division sign. And I need to write down the coefficients. So the coefficients are 1, 13, and 42. Now out in front, I'm going to write down the opposite of this number. So if I have a plus 6, I'll write a minus 6. If I have a minus 6, I'll write a plus 6. So change the sign. So minus 6. So I'm doing two things. I'm taking the coefficients of the numerator and just writing them down. And then from the denominator, I'm taking this number and changing its sign. So if I had x minus 6, then I'd write a plus 6 here. Since I have a, you always change it. Yep. It's just the way this works. I mean, you could get some insight into this process if you spent a lot of time with it. But I think what's beneficial to us here is to really spend the time on the mechanics, is trying to understand how this process works. So now this first one is kind of odd. We're going to understand there's a 0 here. And that's the only time we have to do this in this process. But yes.
Why don't you put the x in front of it too?
We don't need to. The idea with synthetic division is that we're gonna streamline this process and do it really quick without having to put the x's and all that other stuff. So this is no longer long division. Synthetic division only works though if I have a binomial in the denominator like this: x plus a number or x minus a number. The coefficient of that x has to be 1 in order for this to work. But if it is a 1, then you get a lot of amazing information out of this, most of which you're not going to see until your college algebra class. Okay, so let's add these things going down. And there's really going to be two operations here all the way up into the end. Now this number here is going to be our remainder. And the rest of this is going to be our quotient. That's going to be our answer. Now this one's kind of special because we can work it in a different way. Can anyone see how this term up here would factor? X plus 6, x plus 7, right? So if I divide this, well, I can just cancel these out, and I should be left with x plus 7, right? That should be my answer when I'm all said and done. Let's see how my answer here with synthetic division compares to what I get over here. By the way, notice that there's no remainder in doing it this way. I just get, remainder of 0. All right, so the process of synthetic division works like this. We're going to add these numbers to go down, add to go down, and multiply to go kind of up, and you're going to go up and to the right. So 1 and 0 gives me a 1. Now what am I going to multiply by? I'm going to multiply by this number out front. Negative 6 times 1 gives me negative 6. And then the process repeats itself. Add to go down.
Where did you get the 0 from the first start?
You have to just put it there. Just understand that first one's going to be 0 always. Yeah. Kyle?
Was that 1 just from the 1 plus 0?
Yep. 1 plus 0 is 1. Negative 6 times 1 is negative 6. And now this process repeats itself. Add going down. What do I get? 7. Then multiply. Negative 42, and that goes up here. Add going down. 0. So that's our remainder, which is what we expected. We didn't expect a remainder. And this somehow represents your polynomial. And these are just the coefficients of your polynomial, right? There's your 7. 1 is the coefficient of x. So this really represents x plus 7, remainder 0. So nice. Now, it wasn't a huge maybe savings of work in this particular problem, but overall it's a lot faster and a lot more efficient. Jamie, then Nikaya?
So, you're putting the 0 there first. Is that to get the 1 that's going to be x?
There's just always going to be a 0 here.
How do you know where to put the x at the end?
How do you know where to put what?
The x at the end.
Well, when you're all done, these numbers here are going to be, first of all, a constant. That's going to be the coefficient of x. The next one would be the coefficient of x squared, and then the next one would be the coefficient of x cubed. So these numbers will tell you what your answer is going to be.
So x would always be like the second one too.
X is always the second one, and then x squared, and x cubed, etc.
That's always going to be like addition between them, right?
Yeah, but if this was a minus, if this was a minus 1, then it'd be a minus x. And if I had a minus 3, it'd be a minus 3x squared. So the signs will take care of themselves. So you add going down and then multiply to go up. So 13 plus negative 6, that gave me 7. But it's add to go down. Well, 13 plus negative 6 is kind of a subtraction, but I'd suggest we stick with thinking of it as adding. There was, yes?
We're multiplying the 6.
The bottom, yeah, the 6 times the numbers on the bottom.
Whatever we're dividing by with what the result is.
Yeah, so that number changes signs, and that's what's going to be used to multiply all these numbers down here. Yes?
Is there any way to go back and check your answers in this?
Sure. Yeah, it's a great way. It's a really good question. If we wanted to check our answer, we should be able to take this times this and get what's in the numerator. So x plus 7 times x plus 6 gives me x squared plus 6x plus 7x plus 42. So 13x plus 42. There was 0 remainder. If I did have a remainder, then I would add the remainder onto this product. But there's 0 remainder, so it checks. So my quotient times the divisor gives me that. Okay, so nice. Yeah, real good question there. Yeah. It's a great question. In the exam, I will have one where it says, do it by synthetic division. So if you do it by long division, I'd mark it wrong. This is long division. And there's nothing wrong with doing it this way unless I say do it by synthetic division. So make sure you know this process. There will be at least one where I say specifically do it by synthetic division. If I just say divide, you might get lucky and be able to do a problem, by factoring. That's okay. But there will be one where I say do it by synthetic division. All right, let's do some more. Let's do another one, problem number 22, in fact. So problem 22 looks like this. 2x cubed minus 9x squared plus 10x minus 3 divided by x minus 3. Okay, so let's set up a synthetic division. First things first, what number is going to go out in front? Positive 3. Good. Now, leave yourself some space here and draw a line. What are the coefficients here? 2, negative 9, 10, and negative 3. Now, between the last two numbers, between the 10 and the negative 3, draw a vertical line. That vertical line separates out your remainder. Now, it's a process of add and multiply, add and multiply. Jamie, what should I put underneath the 2 here? A 0. Let's put a 0 underneath there so that we can add. When you add straight down, you get a 2. What's the next term I'm going to bring up here? 6. And you keep going. Kennedy, what's next? Negative 3, and then what can I put up here? All right, so negative 9, right? 3 times negative 3 gives me negative 9. Rhonda, what comes down here? A 1. And then the last one over here. Yeah. 3 and then a 0. Nice. All right, but please don't leave it here. I need you to tell me you understand what this means. So this is my answer. I got 0 remainder. And that's cool. There's no remainder. But what does this mean? Good. 2x squared minus 3x plus 1. Remember, it's always a constant, your coefficient of x, and then your coefficient of x squared. It kind of increases from left to right. So x squared, x, and your constant. If I had another term here, it would be an x cubed, and so on. So Bailey, we can check this one again. I could take this times this. I should get the numerator. And let's see that happens. Now it takes a little bit of care in doing this, but I think we can manage that. I'm first going to distribute the x to all 3 of these terms. So that'd be 2x cubed minus 3x squared plus x. Then I want to distribute the negative 3 to all these terms. Minus 6x squared. And the trick in doing that is to write the minus 6x squared here. Why? Why would I want to write it here? They're like terms. I can add them. So minus 6x squared plus 9x minus 3. And notice that I've written the like terms together so that it's easy to add for myself. I get 2x cubed minus 9x squared plus 10x minus 3.
That was easy.
Cool. All right, so it checks. It's exactly what I wanted. Yeah, so times the denominator by what you got. And if there's a remainder, add the remainder last. So at this step, you'd put the plus whatever the remainder. In this case, it's 0. Yes?
Okay, so is the constant always going to be the first number after the or like before the remainder? Like is that always where it starts?
Yes. Yep.
Okay.
It's always the constant and then x and then increasing from there.
And then also, so like for negative 3, oh, yeah, like how you did it there with the negative 3 being the last number. For the, or no, for like the bottom where you checked it. Like when I'm going to write my answer, if there was a remainder, like, what if I accidentally put the remainder like with the last number
With
instead
this?
of an x?
Well, I'm not sure where you want to put. You're talking about where to put it in terms of checking it, or here.
No, down at the bottom, like where, or even like in the answer, like what if I put like, so say the
Oh,
remainder was 2, like
oh,
what if I put it
here you go.
1?
I see. So with the remainder, you just put, the remainder over x minus 3, or whatever the remainder is, you put it over the divisor. So that's where you put the any remainder. Yeah, good question. Yes. Yeah, we did kind of 2 steps. I first distributed the x to all 3 terms, so that's how I got this line, and then I distributed the negative 3 to all 3 terms, and that's how I got this line, and then I added those 2 together. Okay, so yeah, if you're used to multiplying binomials and using FOIL, well, these aren't two binomials. FOIL would run out of letters. You need to create a new word with 6 letters. So when you come up with yeah, FOIL plus 2, yeah, you need a little bit more on that one. Okay, let's keep going. I appreciate that you're engaged this morning. That's good. Let's take a look at 28 then. No, 28's kind of more of the same. So but let's do 28. Special long distance dedication to a lonely heart in a math class. All right. So we've got m cubed minus m squared minus m minus 1 over m minus 1. So first things first, what number would I put out in front here? A 1. And then, Colin, what would the coefficients be? Yep, 1 and then a bunch of negative 1s. Good. So give that one a shot. See if you can't come up with this. In this case, I think there will be a remainder. Constant x, or constant m and then m squared. That's not 0. Negative 1 and negative 1 give you negative 2. No, this will all be m's. But no, there's 0 m if you wanted to put it, but you just kind of leave off. Either put a plus there or put a minus there and then 2.
Oh.
That's all right. No, of course I have it. Should be constant m squared. Well, you don't have to keep 0, but there's a 0 coefficient for m, so that should be 0. So that should be like minus 1 here. You can cut down the pound there. Let's right there. Plus number 2 over there. That way. And because this looks like it's multiplying that. Okay. I'll give you a couple different options here. Your answer should be kind of loose. That's fine. What you have is fine. And then that should be. But the coefficient of m is 0. So you don't really need to write that. You can write the remainder over the denominator. Okay, so this process of add and multiply starts here. Add going down, I get a 1. 1 times 1 is 1. Add going down, 0. Multiply, still 0. Add, negative 1. Multiply, negative 1. What do I get when I add? Negative 2. That's the remainder. So I need to interpret these. That's my constant. That's my coefficient of m. That's my coefficient of m squared. So a couple possibilities for you. I've got 1 m squared plus 0m minus 1 plus negative 2 over m minus 1. That's one possibility. But what's 0 times a number? 0. So I don't really need to write that middle term here. Let me give you an alternative to this. M squared minus 1 minus 2 over m minus 1. So I just stuck that negative out in front as opposed to having a plus and then a negative. Either of these is fine. I'll be very happy to see you get either of those. Yes?
I wanted to put everything over -2. Like, where did you get the n minus 1 under?
That m minus 1 comes from right here. So whatever you're dividing by, that's where your remainder goes over. Always. So like in the last one, even though we didn't have a remainder, any remainder that you would have had would go over the x minus 3. Because that's what you're divided by to start with, is the x minus 3. Anything else on 28? Good question. Let's try checking that. What you would have to do is multiply your quotient, which is this part, times this, and then add the remainder. So let's do the check. It'd be m squared minus 1 times m minus 1 plus negative 2. So here we can FOIL. It's m cubed minus m squared minus m plus 1. And when I add the negative 2, I get m cubed minus m squared minus m minus 1. So it checks. Good? It's nice. You're kind of a unique class that you actually want to check that. That's good. There's a couple other little twists and tricks about these problems. So let me show you some of the other things you have to worry about. So we'll do 2, maybe 3 more examples. Next one I want to try would be problem number 24. So we've got 4x cubed minus 1 plus 5x squared over x plus 2. Now there's a couple things that are wrong with this. In terms of if you're going to set this up and do this by synthetic division, there's a few things you got to take care of. Can you spot one of them?
You have to write it in descending order.
Good. You have to write it in descending order. So it'd be 4x cubed plus 5x squared minus 1 over x plus 2. And I'm going to rewrite it one last time because there's something missing here. What's missing? Good. You have to account for all of the variables. So 4x cubed plus 5x squared plus 0x minus 1 over x plus 2. So they have to account for all the variables and in descending order. Well, 0 times anything is just 0. So putting in a 0x doesn't really change this expression from this. Because, well, if you look at all the exponents here, I've got x to the third power, x to the second power, x to the first power, and then really x to the 0 power is your constant. Yeah, you have to have all these powers of x accounted for. So 3, 2, 1, 0. So if there's anything missing, I have to put it in there. Let's do the synthetic division then. What number goes out in front? Negative 2. And then 4, 5, 0, and negative 1. Yeah, that's a 5. It's a terrible 5, but it is a 5. Let's apply a little Photoshop here. There we go. 5. So do your process of add, multiply, add, multiply, and then try and interpret what you get at the bottom. If you leave just a bunch of numbers, you're not going to get full credit. I need to know that you understand what those numbers represent. Okay, so for those of you who earned or walked in late, this is a chance to earn your test. I have them here. Rhonda, what do these numbers look like here, please?
Oh, at the bottom?
Yep.
4,
Mm-hmm.
-3,
Good.
6,
Good.
and then -13.
Perfect. And you come on up and get this. Colin, can you tell me what this all means? Perfect. So, and again, I'll give you a couple ways you can write that. You write just minus 13 over x plus 2, or you can put plus negative 13 over x plus 2. Either way works. Well done. Thank you. Yeah.
So you don't have to put the cubed from the original problem?
No, because when you're looking at the bottom line here, that's your constant, that's your coefficient of x, that's your coefficient of x squared. So there is no more cubed. A different way to see and understand that there shouldn't be a cubed is to just think about the leading terms here. What happens if you divide, say, let me do it over here, 4x cubed divided by x? Remember what happens with the exponents? You subtract, right? So when you're dividing like this, you're going to lose an exponent. So for these types of problems, your answer here, its degree should be 1 less than what you have to start with. So it's kind of a way to double check your work at least a little bit for these types of problems. Yes, sir.
The reason you write the remainder over the denominator so that you don't combine like terms at the end.
Yes, exactly. Because if I just wrote minus 13, then I'd be tempted to say, oh, well, 6 minus 13 is negative 7.
What parentheses work just as well?
If you put r negative 13, I guess I'd accept that. But the reason in my mind that I write it like this is so that if I wanted to check it, I'd multiply everything through by x plus 2. I get x plus 2 times this, which I'd multiply out, and then x plus 2 times this, that would cancel. So I'd just be adding the numerator. So, I mean, that's why I write it like that. And I don't think I'm unique in that either. Let's do problem number 30. Now, problem number 30 is a little bit more extreme version of problem number 24. And we'll look at problem number 30 two different ways. So, b to the fourth minus 81 over b minus 3. If you're going to do this by synthetic division, then there's some work we have to do in the numerator. Emily, what should I rewrite this as? Oh, I was thinking of doing it in terms of synthetic division. We're going to do it that way in just a minute. Yeah, but you're exactly right. In your good. So basically, you've got to put in a lot of missing numbers here, right? A whole lot of them. All these terms that are missing, you have to account for. You have to have b to the fourth, b to the third, b to the second, b to the first, and then your constant. So if you're going to do this by synthetic division, okay, a lot of work to do. Go ahead. Yeah. We're gonna do it factoring in just a minute. Yeah. Emily spotted that one as well, so good on you both. Jamie, what number goes out in front? Positive 3. Good. So positive 3, 1, 3, 3, 9, 9, 27, 27, and magic, 81 and 0. Cool. So, Krista, what do these represent? What's that represent?
X to the third. Oh, B, sorry.
It's okay.
B to the third plus B to the second plus B plus 27
Plus 9b.
plus 9B plus 27.
Good. And 0 remainder, you don't have to write this. If that's a 0, that's fine. Don't write it at all like that. So that's one version, one way to get to the answer. Now, I mentioned earlier that one of the things that I would expect on the test is you'd be able to do a problem by synthetic division. I may give a problem like this and just say divide. So for those of you who see it, there's a different way you can approach this one. So, Emily, I saw you pick it up first. How would you factor this one? Good. Now I can't cancel that yet, can I? What else can factor? B squared minus 9 can factor into b minus 3 times b plus 3 times b squared plus 9 over b minus 3. And now I can do some cancellation. B minus 3 cancels from both of these terms. I'm left with b plus 3 times b squared plus 9. And if you FOIL this out, we'll get b cubed plus 3b squared plus 9b plus 27. And hey, it's a pretty good match for what we got.
Want us to FOIL it out or just leave the B plus 3?
I'd probably accept it like that if you wrote it like that. But I'm curious, which way do you guys like better? Do you like factoring or do you like synthetic division? Synthetic division? Okay, cool. For this one.
I would go with factoring.
So,
Because I could see it faster.
sure. And that's why I said, there will be one where I say do it by synthetic division, and there's another one where I'll say just divide. And so I'm kind of leaving it up to you.
Especially if you use a perfect square,
Well, this one's pretty nice, yeah. All right. Let's see. Are you getting pretty good at this? Okay. Well, good. Let's try problem 38. By the way, Krista. And Jamie. So here's where the real benefit of synthetic division comes in, is when you have uglier problems like this. 2.7x squared plus x minus 5.2 divided by x plus 1.7. So let's set this one up. What number is going to go out in front? Negative 1.7. And then a 2.7. What's the middle number? A 1 minus 5.2 over, well, we're going to have to figure it out. Tell you what, I'll do the first one for you. 2.7. Yay, I'm so helpful. For the next one, maybe you want to take out a calculator. Are you guys getting the same numbers as I am? No? Uh-oh. Let's see here. Yeah.
Negative 4.59 instead of negative 1.89.
Oh. Where did I screw up on that? Yeah, no, that's... Wow. Alright, so let's apply a lot of Photoshop here. There we go. So negative 1.7 into 2.7, 1, negative 5.2, and there. 2.7, you know, 1.7 times 2.7. Yeah, I don't know how I could have gotten that one. 5.49, so it'd be negative 3.59. 7, 6.103. Does that look better? Minus 5.2. So 0.903. All right, still looking good? Okay, then let's interpret this. What does this mean? Amanda, you give me a help on that one? Perfect. Thank you. Yeah. No. Can't. Yes. Can you multiply by 10 to simplify these things? No. You can't. You just really can't. Not with this method. If you're going to do long division and multiplying by 10, you'd have to multiply by 10 in the numerator and denominator. And then you'd have 10x plus 17 in the denominator, which is okay. But if you add something other than a 1 right there, you couldn't do synthetic division anymore. So, yeah. You can multiply by 10, but you wouldn't be doing synthetic division. All right. If you're pretty confident on that one, let me give you some homework. For homework, try 13 through 39.